Hi,
Hi, Bernhard.
Carsten. So, is this or what are we going to do in this one? Because I see you have Failover Cluster Manager open. We have a look at our VMs, and there seem to be quite a few now, right? So they
Yeah,
have.
there are plenty. There are plenty. Last video we deployed with
Hmm.
VMFleet 35
Yep.
benchmark VMs. Let's call it benchmark VMs on
Hmm.
every node. So we have
Okay.
4 nodes times 35 is 140 VMs, and there are some other roles in our cluster. You maybe
Mm.
remember the big
Yep.
VM, IO meter,
Of
and
course.
our 3 Linux VMs, and then we have some additional roles in our cluster. So here you
Hmm.
see, if we
Okay.
do a VM dash here, you see we have, oh, the big VM is also a VM in it.
Well,
Yeah.
good.
So
And they are equally distributed amongst the nodes, as I would
yeah,
assume, right? So you
let's
have.
see here. That's not, the naming is nice. So we have the host
Mm.
name or the
Right.
volume name in the name of the VM.
Hmm.
And when we scroll down, we have 001 to 035, so 35 VMs on the first node.
Okay.
You see here, there are also the owner node is the first node. The
Okay.
VMFleet is there, is very precise where it puts the VMs. And even if you look into one of the VMs here in the properties
Hmm.
of the role, you see the preferred owner is the host
Mm.
2. And this is
Okay.
a first VM of the second setting. So here,
Hmm.
if you go down,
Okay.
they are all out. And now we want to play around with them, right?
Yeah.
There's
So
another
do
VM
can
node.
you do me a favor and maybe have a look at one of these virtual machines at its setting at to know
Of
to
course I
see the
can.
size. Yeah.
Settings, you see
Okay.
here, this is by the way an Azure size, right? I think they emulate an A1 VM. So
Okay.
one processor, a weird number of megabytes,
Hmm.
right?
Okay. Yeah.
Um, yeah, we have that. Then we have
Okay.
our internal switch. We talked about that
Hmm. Okay. There is
before.
some. Are you happy with these settings, or would you want to change
No,
these?
actually not. And I can be wrong, but
Mm.
I think the old VM fleet,
Hmm.
uh, with the new one, everything is better. Of course, it's a new one, but one thing is maybe not
Okay.
good. But I have to double check it
Okay.
because our VM is the automatic stop action is on save. And Bernard,
Right.
what happens when it's on save?
Yeah, I mean, if you're, there will be quite, the space of the virtual machine would be reserved on disk,
Yes.
whereas, and this is, currently maybe not so good because you, the test of this VM fleet is like, you want to max out the storage capacity of your volumes that you created in order to test everything, the performance of
Yeah.
everything. And then you might find out that you need additional space or half of your VM fleet VMs cannot start because of the save state, right? Because this one needs to be on disk um, at the time the virtual machine
Yeah.
starts,
So
right?
to show this,
Mm.
we just will start. I'm here in the
Mhm.
directory of the first VM of the first node. So we go up
Right.
here. Yeah, that would be this one.
Hmm.
Here we also have this setting. So it's on every VM.
Hmm. Yeah.
Save. And if we look into the virtual machine, here's our configuration. You see the
Yep.
kilobytes. And when
Hmm.
I start the VM,
Hmm.
you see that our
Yeah.
third file, the VMRS file, is
Hmm.
now 1.8-ish
Hmm.
gigabyte. And this is because there is this save in the VM. And
Hmm.
funny story, I had a customer who was very space sensitive in their cluster, and they had a lot of exchange servers, and every
Mm.
exchange server was with 100 gigabytes of memory. They had 140 of them. So
Mm.
they didn't know about this, and they lost 14 terabytes of disk space
Mm.
because this setting. So you have to. rethink this setting in
Mm,
a failover cluster. Usually the virtual machines are moved to another host if you shut down a
mm,
host, so no need for the safe state.
yeah,
In a standalone server there is maybe still
yeah.
uh, a need for that. So I shut down this VM again. So what can we do about it? You wanted to provide me with a little script, right?
Yeah, have a look at that at the private chat. I copied the code there. So it would be now your task in order to do that for the 140 VMs or 145 VMs or
Yeah,
44. But now let's see if my PowerShell script works.
yeah.
In order
It
to do.
better will, my friend. I copy it just over.
Yes. Okay.
So
To get.
it's I have
Yeah.
to. I think it's not. It's not
Yeah.
working.
I think you may have. It's two lines actually, right? So you shouldn't have get
It's always the
VM,
same. No, why is it two lines?
get cluster resource. Yeah, so no, the go to the virtual machine and then hit right in the middle, make two lines out of this. It's just one line. Yes,
Where?
here. Before the cluster VMs. Before
Okay.
cluster VMs, that should go in the next line, right?
It's always the same.
I mean, copy.
You can't copy and paste.
Hey, it's
So
what your video editing tool is making it about, right? So it takes the virtual machines, it finds it on the cluster, and then it will set this value to do the job for all of the VMs it could find, right? So let's see if that works.
yeah, it's done. So let's see again. And here, the PowerShell magic. I pick one of them and here shut down. So very well, Bernard. So we've done that.
Okay.
That's a little sidestep. We
Yes.
can't do only the necessary stuff. We have to give you more information, right? So,
Yeah, I mean, I think that's the idea of a training video or sort of like, but anyways, so what do we have here? All right. So,
okay. So
so
now I will start the VMs, I would
mhm.
say, right?
And yes, and by the way, I mean, if we would have wanted to change the size of the virtual machines used for VMFleet, there is a PowerShell commandlet for doing so. So you
Yes.
could set
Mm,
fleet VM something, I think it is, and there
yeah.
you could specify the amount of memory, the processes to be used, right? So you can
Yeah.
tune that.
Yeah.
Okay.
But to be
Yeah.
honest, we could do a 5-hour series just about VMFleet.
Okay. Yeah.
There are so many commandlets and there's so much great
Yeah.
stuff, but we should concentrate on the necessary. We'll give you some additional information, but Bernard is
Yeah.
right. You can change the processor count and the amount of memory. The processor count is maybe something you have to think about, but we will talk about it a little bit later, right?
Yeah. Hit start. I mean,
I hit the start, yeah.
because
And
these virtual machines take some time to boot up,
yeah,
and we could use that time for further
yeah,
education or not.
exactly. So we will do that. We go to settings again.
Hmm.
You see here, every VM is a one logical processor or virtual processor VM.
Hmm.
And when we went through the settings in our Azure Stack HCI cluster, there was something called core scheduler and
Hmm.
classic scheduler.
Hmm.
And because of security reasons, an Azure Stack HCI class and also from Windows Server 2019 Hyper-V clusters use then by standard the core scheduler. Core scheduler um, is main purpose is to not put two different VMs on the same threads of the same of one core. So in our example, we have only one core VMs, and so basically the core scheduler will only use one thread of a core, not the second one. So we lose a bit of performance, right, Bernard? If we would change to the classic scheduler, um, VMFleet would get more processor resources. Let's say that.
Hmm.
And we did a little bit of a video about how the VMFleet is running on this host with the classic scheduler. You have to decide if you want the last bit out of VMFleet benchmarking and go to the classic scheduler, or you stay with the core scheduler. It's a scheduler Microsoft. Um, um, it's a default. They heavily um, how you call it, say to use that scheduler, not the
Yeah,
old one.
they recommend
It,
it. I mean, it's
yeah, they recommend
the more secure way for
scheduler.
operating guest virtual machines, right?
Yeah.
More isolation areas in there. Yeah.
So VMFleet has its own bench or its own visualization tool. Yeah, we
Hmm.
of course we can go to Windows Admin Center. We will see the I/O, but
Hmm.
VMFleet also has its own tooling for that, and it's called Watch
Hmm.
Fleet, right? Watch
Hmm.
Fleet cluster.
Yep.
And if we just do that, I'm on a host of the cluster. So if I just do it, you see this output here. Yeah,
Hmm.
it's showing us the cluster shared volume file system where our VMs live. Yeah,
Hmm.
remember we have 35 VMs in every volume. We have 4 volumes. They are
Hmm.
named like the hosts. Yeah,
Hmm.
but you see here, we see the IOPs. The green
Hmm.
numbers are always the sum of all hosts, and then we see the IOPS per host. And this is the read and the write uh,
Hmm.
IOPS. Then we have
Hmm.
a column for the read IOPS, for the
Hmm.
write IOPS. Then we
Hmm.
have the bandwidth in megabyte per second, yeah,
Hmm.
and then read and write. And
Hmm.
for us, the important things are the read and the write latency
Right.
and the queues, the
Hmm.
read and the write queues. So you see here, there's
Hmm.
nothing going on. I started 140 VMs and there's
Yep.
really not much there. This
Hmm.
is because if we look into a VM,
Hmm.
just let's see here, we
Yeah,
saw it
they're idling,
before.
right? They
Yeah, they are not allowed to do something. They are in
Yep.
pause mode. And I did a little bit of a joke in the last video that the developer of VMFleet has a little bit of a color problem because a red pause is in red.
Hmm.
It means usually red means error. It's not an error here. It's yeah, the pause. They are waiting for the allowance to do storage stress,
I
and
think
we
it
didn't give it.
is, the a traffic light, right? So red means
It's
stop,
red. Don't
right?
go. Okay, maybe you're
Yeah,
right.
maybe. Yeah,
Yeah.
but
Okay. So first, let's talk about this watch cluster.
Mhm.
Watch cluster or watch VM fleet cluster has a lot of. It can show a lot of different
Mm.
information about what's going on, and there are 9 packets. Yeah. So if we do this watch cluster, there are some options. We can run it remotely,
Mhm.
not or for another cluster. We
Yep.
can specify how often it updates the information on the screen. Let's say we do
Mhm.
it every 3 seconds. And
Mhm.
then there is another option called sets. And
Mhm.
this, what we see here, the CSVFS is one set.
Mhm.
So if we do show me all sets,
Yeah. Okay.
there are 9 and we
Mhm.
do that, it can't put it in this PowerShell window without scrolling. So
Yeah.
we have to downgrade the font size. Yeah, and
Okay. Yeah.
we will not use all of them, but just to
Mm.
show you. Yeah.
Mhm.
So if I
Yeah.
do it bigger here, I know that you know that, Bernhard. We
Yeah,
will
but
show our viewers.
do we really need all of it? I mean, would it be okay?
If we would do a deep dive and
Mhm.
really go
Mm.
into it, maybe. But I
Mhm.
usually don't use all of them. I
Mhm.
use
Which?
the CSVFS.
Okay.
Yeah. If we have caching devices, I also use a software storage bus cache.
Mhm.
We see
So
numbers here.
NVMEs in front of SSDs and
HDDs,
and
SSDs.
HDDs.
Yeah.
Right. Mhm.
We don't have that. We have a flat NVMe design, so nothing will go on in this packet, so
Okay.
we don't show
Mhm.
it.
Mhm.
Then we have the software bus layer. That's interesting.
Mhm.
I included.
Mhm.
Then we have the software bus layer local. We have it remote.
Mhm.
We have an SMB server. the
Mm-hmm.
S2D bandwidth. Here are some numbers communal from different packets, and we
Mm-hmm.
have the Hyper-V CPU usage.
Mm-hmm.
That's interesting, and we
Mm-hmm.
have the SMB transport. So I usually show this,
Mm-hmm.
the CSVFS. If we have caching devices, I would add the
Yep.
SSP cache.
Yep.
Uh, if not, and anyway, I do the SPL and I do the Hyper-V CPUs. Yeah,
Mm-hmm.
but you can choose from what you want, but that is what I usually do, and that's all the information I need. So we
And
can
these values come
specify
from the performance counters, right? So these are
exactly.
ingested from the performance counter. So if you want to see what everything is, you might, go to perfmon, load up the drivers from that category, right?
Yep.
And then dig for yourself
Yeah.
for the description, right? Okay.
Yeah. So let me say something about the performance counters.
Hmm.
Sometimes the
Hmm.
systems are so busy that
Yeah.
they can't read the performance counters remotely. Then you have
Yeah.
maybe not a number here. That's not that doesn't
Right.
mean it's defect, but there's a
Yeah.
lot of work that this script does, and
Mm.
has to sum up everything. So it needs some time, and sometimes the time is not enough to do
Mm.
that. So don't
Yeah.
worry.
Sometimes, yeah, and maybe adding a higher sample interval or getting less counters may help you,
Yeah,
or might be helpful on this one,
yeah.
right? Not to
Uh,
overload the system with
e-
dragging performance counters. Okay.
exactly. And one
Hmm.
more information: if you, for example, turn off hosts or reboot
Hmm.
them,
Hmm.
it can't read the values, and
Hmm.
it will do that. Try to do it multiple times, but there is usually a time where then nothing is shown anymore. So that doesn't mean there is no IO in your cluster anymore, but the script gave up. So you
Hmm.
stop it and start it again, and you have counters. So I
Okay.
usually also test, maybe if I have a 4 node cluster, the grand final finale in my tests are turning off 2 of the nodes
Hmm. Hmm.
and showing what the VMs are doing, for example. We can maybe do that here too in an additional video
I
because
like
this
the
will be long. Yeah. Yeah.
final
The the
final
the
exercise.
grand finale. So
The grand
um
finish, yeah. Okay, so
so
yeah, so they are currently in pause mode. So I would assume that there's also some sort of a action mode. Um,
it is.
but
We can say clear. Yeah.
yeah, but before you do clear, what are we going to test, right? Because I mean, we
Yeah.
remember the iometer test. We spent some time on defining the load pattern, right?
Yeah.
Um, which kind of load pattern are we using here? I mean, is it
We will look after it.
okay?
There is there is a script for that, what the
Hmm.
VMs are doing. But
Hmm.
first, let me just clear the pause and
Okay.
see what the system is doing.
Hmm.
So let me finish my Outlook here. It's
Okay. So what are we seeing, Carsten?
Yeah, we see here a lot of is
Hmm.
going on the host. So
Hmm.
there is something happening. Yeah, but
Hmm.
and we see it here. Yeah, we
Wow.
see it here.
Hmm.
And we now do the standard test that is Microsoft delivering with VMFleet. And to be
Hmm.
honest, I don't think this test is very good. If you look here, we have 1 million IOPs. Great, really
Hmm.
great. So, and we have nearly the
Okay.
same amount in as read IOPs and
Right.
nearly nothing in write. So, which
Hmm.
system has only reads? If you want to stress your system, you have to add a bunch of writes, right? So
I know
here,
which system. The sales system. The sales
it's this,
system.
yeah, it's a marketing or sales
Yeah.
system. It's doing well. We get our 1 million IOPS. Everybody's happy, but you
Mm-hmm.
don't know how it's really behaves. So
Yeah.
you see here a lot of we move 5 GB of IO, but it's mainly local because the VMs are
Mm-hmm.
running on
Mm-hmm.
the owner of the volume and it reads everything local, so we don't
Mm-hmm.
have to use our network heavily.
Mm-hmm.
That will be done when we do a lot of writes. And here you see our latencies are not
Mm-hmm.
even the writes are not even so good,
Mm-hmm.
and there are not very many. So what is
Yeah.
this thing doing? Yeah.
Mm-hmm.
So we have a when we go to the collect volume. So I'm here
Mm-hmm.
now at a system with a GUI,
Mm-hmm.
and we go remotely to one of our nodes, $C cluster storage collect.
Mm-hmm.
Our VMFleet installed here the control directory, the flag, the result,
Correct.
and the
Mm-hmm.
tools. And
Mm-hmm.
if we look in the control directory, we see a
Okay.
run.ps1.
Mm-hmm. And this is the file that the virtual machines, like the one in the back, are getting and evaluating, right? Or what?
Exactly.
Mm-hmm.
Loading and running, right?
Mm-hmm.
So
Yeah.
what did I do now? I thought I opened it in an oh we do. We didn't want to run it, we want to show
Yes.
it, right?
Yeah.
So this is the default file that is done,
Mm.
and
Mm-hmm. Mm-hmm.
it's using disk
Using this
speed,
speed.
yeah,
Correct.
with
Mm-hmm.
a lot of options. Yeah.
Mm-hmm.
And you can create your own file or you can modify this file. So
Mm-hmm.
what does this file do? So in line 3, we
Mm-hmm.
have our tests. So we have some variables here. $B is the block size. So it's
Mm-hmm.
4K. I
Mm-hmm.
usually like more to do 8K, and I will do
Mm.
that.
Yeah. So
Then we
it's not
have,
buffer size, right? It is because in line number 2 it says buffer size. I mean,
yeah, buffer
no,
size
but
alignment, but
yeah, yeah.
it's in
Mm,
K, so it's doing 8K
mm,
writes and reads, and it's
mm,
aligned and everything. So then we have the number of threads. What is a
mhm.
thread? It's like the worker. If you remember IO meter, we
Yeah.
had, I think, 8 workers, right? Eight
Mm,
IO streams that are doing IO in parallel.
mhm,
This test in the moment is only doing one IO stream.
mhm,
Yeah, but this IO stream has 32.
mhm.
Is allowed to have 32 outstanding IOs. So it can do
Wow.
read, write, read,
Mm,
read, read, read. In this example, it would do read, 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 read.
yeah.
And if the 30-second read is not, or the first read is not back when the 30-second is put in the queue, then we
Mm,
would wait a bit. Yeah.
yeah.
So this is, we will
So the
change it. This is
final numbers will be calculated until the last request has been moved from the queue, right? So
yeah.
everything. Okay. Yeah.
I think so, yes. So
Mhm.
I usually do with VMFleet, I do a 30% write test,
Okay.
not a 0%. So we will have
Mhm.
70% read,
Yeah.
30% write.
Mhm.
And I will go to the old values because
Mhm.
I know how a cluster should behave with the
Mm.
old test. This is a new one. They have a new pattern. The old
Right.
pattern was 8 threads,
Mhm.
20
Mhm.
outstanding IOs per thread.
Mhm.
30% right. And I usually take the 4K. There is an example in the old VM fleet. It's called run demo 7030.
Mhm.
And I copied that usually and modified it to 8K, not 4K.
Mhm.
And we will simulate the same test. So this is a
Mhm.
test
Okay.
I've done in hundreds or even thousands installations,
Yeah.
and I know my numbers. So what a system
And I,
with
yeah.
a specific design should be normal in that system.
And I think
Yeah,
it's an important piece, right? Because I mean, depending on which parameters you use, the test could be completely different, and the numbers could be completely different. So
exactly.
you want to compare apples with apples and not with pears,
Yeah,
right? So therefore, be sure that you know always use the same value, right? So
exactly. So you
when
can
you come,
use different
Mhm.
values. Yeah, you
Yeah,
can make up your own test, but we defined
yeah,
ages ago, let's say, I think 2015 or so.
yeah,
That's how long I do storage basis direct. Even before Windows Server 2016 was out, I did already POCs at customers with storage basis direct. Yeah,
yeah,
so I defined somewhere around that time frame what test we do, and now we do
mhm,
the same test every time, and we have so many tests done. So
yeah,
we see maybe there's something wrong in the cluster, and we
mhm,
talk about that later. So if I now would change my pattern,
mhm,
I start fresh, right?
mhm,
So,
yeah,
but if we do that now, it will
mhm,
kill the cluster, yeah, because we have 140 VMs
mhm,
doing 8 threads in each VM with each thread has 20 outstanding IOs. I can save
mhm,
them. I
mhm,
do that.
yep.
And
Mhm.
if we look at the numbers, oh,
I
what was that?
think you might need to use a different tool. It might be
No,
in
no,
use
no, no, no,
personally.
no, no.
Or
There is a trick for that. You just you just delete it here,
mhm.
then you save it again.
Yes, you seems that you spent quite some time with it.
Yes, I did. So now we have a new run file.
Hmm.
Yeah,
Hmm.
it's they should load it,
Hmm.
and
Automatically.
we
Yeah, they.
automatically
Hmm.
we should see that here. Come on. You see here, stopping reason new run file. It will load,
Hmm.
it will copy the new run PS1 into the VM, and then it will
Hmm.
starting that test. But we don't
Okay,
see
nice.
any numbers here, right?
Yeah, no.
So we go to our this system here,
Hmm.
and now we see a completely destroyed system. Yeah. So this is not what we what we want to see. We see a
Yeah,
lot of IOPs. There were
yeah.
more before, but we see we have 260,000 write IOPs, and before we did
Hmm.
4K, now we do 8K. So we
Yeah,
move much more data, nearly
but where?
double the data.
Yeah,
Yeah.
but where is the point where you say it's not
Yeah, the
looking good?
problem is here.
Mm. Mm.
So you could say, oh, great, I have now a system that can push 860,000 8K random IOs and
Mm.
30% are right.
Mm.
Fantastic, but you can't
Mm.
use it because we have a write latency in the storage layer. It's not even the VM. In the VM, it's even worse, where
Mm.
we have every write has a latency of, let's say, 8 to 40
Wow.
milliseconds. And
Mm.
it will get maybe worse because the queues here, there
Hmm.
are over 1,000 IOs are still waiting to be processed, right?
Mm. Yeah.
So this is really too much. And if you download the old VMFleet and just do the
Yeah.
tests, you have the same same result. You don't really measure a system that you
Mm.
can still use. Yeah, you
And you
just
could all, yeah.
you throw a lot of IO on it, and it's not useful. But you can show off your numbers here. So we
But
want to
you
have a
could also,
system.
yeah, you could
Yeah,
also argue. I mean, look at the host's total CPU usage, right? It's above 90%, which is, I think, not a very, yeah, healthy.
it's it's even worse. You see here,
Yeah, yeah,
it has
yeah,
problems to
yeah,
show the
yeah,
numbers. You see here we have 100% CPU load. Yeah,
yeah,
the system is toast. Yeah, but we
yeah.
will now
Mm-hmm.
change it
Mm-hmm.
because I want to see here decent numbers. So I want to
Mm-hmm.
see maybe a write latency of 1 millisecond, max 3 milliseconds, but usually around one
Mm-hmm.
millisecond or
Okay.
better below. And then we would I would like to see what we get here. So we will not get maybe 880,000, but we will
Mm-hmm.
get more than 500,000, and the system is still
Mm-hmm.
responsible. We can work with it and so on. And that's the important number for me, not this,
Mm.
yeah, this crazy stuff here. So
Yeah,
how
yeah.
do
So
we
I
do
mean,
that?
you wanna approach the values where you could still say, hey, this is the system where it behaves well, where I get decent performance. Maybe I should not run more virtual machines
Exactly.
with more IOPS on it because the system will get toasted, right? So
Exactly.
how are you going to do that?
Yeah. So in the past, I added in the PowerShell run scripts, there was
Mm-hmm.
not an option to limit the I/O
Mm-hmm.
that a VM could do, but
Mm-hmm.
disk speed already could do that. So you had to add a parameter minus G,
Mm-hmm.
and then a weird number. So you had to add the bytes a thread would do per millisecond. So I
Mm-hmm.
had
Okay.
I had to calculate how much an IOP when I want to have 1,000 IOPs in my VM. I
Mm-hmm.
had to calculate how much bytes would that be per thread per millisecond. It's not too
Mm-hmm.
complex, but now it's much easier. You see here in our run script, we have a dollar IOPS.
Yeah.
It's it's masked out, so it's not used in the moment.
Mm-hmm.
But this number is again per thread. So
Mm-hmm.
they calculate the IOPS per thread. If I would use 500 times 8,
Mm.
we would allow our VM to do 4,000 IOPS. Yeah.
IOPS. Yeah.
So
In
we
total.
we do
Mm.
that. Yeah.
Mm-hmm.
We save it, and this time it saves it, right? No error. Nice.
Mm-hmm.
And if we look in our VM, we don't
Mm-hmm.
have any open. Let's click
Okay.
here.
Yeah.
Yeah, it takes a while. It's still busy. Our nodes are still very busy. You see it here. So
Mm-hmm.
6:35. The VMs are not at German time, so I don't know if there was a reload.
Nah, from the
I don't.
timing, I
Yeah,
don't
now
believe.
it is. Now it is.
Yeah.
See, the system is a bit slow. The reaction
Mm.
is slow because it's really working at
It's
100%
it's
secure.
toast, as you said, right? So
Yeah,
it's
it's toast, but it will. We will untoast it. Yeah.
yeah, I mean that would be that would be the time when you would see that the watch fleet cluster will show a drop, maybe, right? Go down and then reload and then start again from scratch,
Yeah,
right?
look
So
here.
yeah.
We maybe got the last VM that reloaded the I/O,
Hmm.
because in the moment we see, so we
Hmm.
have 4,000 per VM.
Right.
Yeah, 4,000 IOPs. So you can do math with PowerShell. I normally don't do that, but it's just typing, right?
Hmm.
4,000 times 35.
Hmm.
That's 140,000 per node.
Hmm.
And you see here 140, 138, 140, 40. This is a bit slow. It will
Mm.
catch up maybe. So you see here
Getting closer.
three of the four systems are already doing roughly around 140,000 IOPS,
Hmm.
exactly what we allowed it. And if you look here, it's 560,000 IOPS.
Hmm.
Look here, look here. We have a
Wow.
write
Full.
latency
Hmm.
around zero point 0.4 milliseconds.
Hmm.
Yeah. And the queues are
Not.
manageable. So
Yeah.
there are 17 IOPS there. The
Hmm.
average queue depth, it's of course it's busy, but you can
Hmm.
still work with it. We could start an IO meter in another VM. Maybe
Hmm.
we do that, and we see that it still works. We can still work with our VMs. And you see here we have a little
Hmm.
bit CPU left, yeah?
Yep.
So we can increase our IOPS if we
Hmm.
want to, and we will do that because I want to show
Hmm.
you. So maybe we go to 600, all right?
Hmm.
So what I usually do when the customer, I look for the system, I
Hmm.
increase the IOs that the VM can do, um, unless to a point where we get around, let's say, 1 millisecond, and then we have still a decent system. It's very busy, and then we see the IOPS. So usually you should get, depending on what systems you have, what storage systems you have, how much nodes you have, what your
Hmm.
network is. But when we talk about a four node cluster
Hmm.
with, let's say, 225 gigabit network between the nodes, more is even better.
Hmm.
Yeah, so for our east-west traffic, our SMB3 traffic, we have 225 gigabit NICs. Um, and you have decent storage, you should see 400, 500,000, 8K IOPS, full random with 30% write, and 70% read. Yeah, and your
Hmm.
latencies should be around 1 millisecond. So this system is doing very well. We have 670,000, still below 1 millisecond. And you see here, every system is doing 160,000, nearly 170,000. So we can
Hmm.
play around a little bit more and say maybe let's do 700. Yeah, and then we
And
are
maybe
already.
just to mention this, I mean, this is all full random, right? So you have it
It's
in,
full random. Yeah,
right?
it's
And
really full random.
yeah, it was the R character in the run file, right?
Yeah.
So you could specify sequential, but
Yeah, and you can test other block size. If you
mm,
increase your block size, of course, much more data is moved. So here
mm,
is more data, and then of course your latency goes up because a write takes longer. And
mm,
yeah, the disk can only do so much, so you can't write a 1 megabyte block in the same time than a 4K block. The other one
mm,
is 250 times bigger, right? So it
mm,
takes longer. Yeah? But you
mm,
see here now we are over a millisecond. Yeah.
mm,
We
Mhm.
are at 70, 80. So maybe it will come down a bit, but now we
Mhm.
are nearly 200,000 per
Mhm.
node. So this is, we get to a point where the system then can't handle the IO anymore,
Yeah.
and the write queues get longer and longer, and then the latency also gets
Mhm.
up and up and up. So this is too much,
Mhm.
but it's just playing around a bit with the points. So if we go down to 650, maybe the
Mhm.
system can handle that. And always remember, this is per thread, so times 8. That's what
Mhm.
our single VM is doing. We have 35 on
Mhm.
every system. So I'm still amazed what Storage
Mhm.
Spaces Direct and Azure Stack HCI can handle as
Mhm.
IO. We are talking 140 VMs here. Yeah,
Right.
140 VMs are really killing the system. Yeah? Okay, so
Cool. Yeah, that's a cool thing. I mean, there is one thing, and I know you might say, "Hey, should we really want to do this?" But I also like, the storage course flow command let for having a look at the disks, right, or the volumes.
yeah, we have different possibilities what we
Mm-hmm.
can use. One thing would be using old possibilities like the storage quas.
Mm-hmm.
There is, we can see. Um,
Mm-hmm.
let's
Oh.
do it. Get storage quas flow. Yeah,
Mm-hmm.
it
Yeah.
will show us numbers. I do this a little bit bigger so that we have more space, so that we can see more columns. It will show us for every virtual disk in the system. So it's not per VM, it's per
Mm-hmm.
virtual disk. There are counters there that are, the system will just um, take the counters per virtual disks, and the
Mm-hmm.
storage quos flow or the storage quos policies are usually to limit or guarantee storage bandwidth for VHDXs.
Mm-hmm.
So, for example, if you have users, if you are a hoster and you want to guarantee, or you don't want people that use all your storage bandwidth, because they do disk speed tests or whatever, and then, of course, other VMs are maybe suffering, other customers maybe are suffering. So you can limit what a virtual disk can get on as
Mm-hmm.
storage, how
Mm-hmm.
many data can be moved, how many IOPS can be done.
Mm-hmm.
On the other hand, you can also guarantee IOPS and bandwidth. For example, if you have some SQL VMs and you want to guarantee that these VMs get more IOPS if they need it than other VMs. Yeah,
Mm-hmm.
this is usually why we have these storage cross policies. But we can also use them to see what's going on.
Mm-hmm.
And but uh, you have to know some things. These numbers that we have here are not the numbers that are just from the time where we enter the command.
Mm-hmm.
These are 5 minute um, averages. So in the last 5 minutes, we had a latency of 1.8 millisecond in this VHDX. We had a a 5,141 IOPS per second over the last 5 minutes. If we would stop the VMs now, we
Mm-hmm.
would see that the initiator IOPS would go down, but they would
Mm-hmm.
not be zero. Yeah, they would
Yeah.
go down, 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 and after 5 minutes, the VM not doing nothing. That would be at
Mm-hmm.
10 or whatever. Yeah, and so if you start the VMs, it's the same. They increase over the 5 minutes. And this is also the initial bandwidth, right? So these
Mm-hmm.
are 5 minute average values. Very
Okay.
important. Okay.
Mm-hmm.
Another thing that we can use is our beloved admin center. Yeah. So I have my beef with some things in admin center, but this part I really like. So
Yeah.
the visualization of data. I really like. We get nice graphs, and
Mm-hmm.
our admin center is maybe a bit slower now. Why? Because we are doing a humongous amount of data is moved around, and we have
Mm-hmm.
a huge processor load. But if we just go to the volumes here, we
Mm-hmm.
see here, yeah, we are on the summary of all volumes, we see the IOPS, the
Mhm.
latency, and the throughput
Mhm.
in the whole system. Yeah, and
Yep.
these are 10-second values. So these are not 5-minute averages. These
Yeah.
are 10-second averages, still averages, right?
Mhm.
And you can, this is good for an overview. So we see 5.5 gigabytes of data are moved in the moment. We have an average latency of half a millisecond. Yeah, but it's
Mhm.
average. That's
Mhm.
over all reads and all writes over the last 10 seconds per. Yeah.
Mhm.
So if we want more detail, we go to inventory,
Mhm.
and most people don't know that, but you can modify the columns that are shown
Yeah.
here. And I
Yep.
already did that. You see here, we have
Yeah.
IOPS here per volume, and we have the average latency. If you press this column picker, we could also add here the total throughput. Like
Mhm.
this, we kick out, save. So now we see how many data is moved per second.
Mhm.
Again, I think 10-second average. We
Mhm.
see our latency, and we see the IOPS. Yeah. But also it's always a sum. So it's a read and write IOPS.
Yep.
It's the latency over every IO in this volume, and this
Mhm.
is the total throughput. If we
Mhm.
click on the volume,
Mhm.
we have also charts here. And now we see read and write IOPS. We see
Mhm.
read and write latency. We see read and write throughput. Yeah.
Mhm.
And here we really see nice, it's very smooth. The latency, the write latency is of course
Mhm.
longer. Normally it's longer than the read latency. So we have 0.2 milliseconds read and we have 1 milliseconds write. Yeah, and we see the data more is read than written. It should be 70-30, and also here the IOPS. And now we can even go deeper with Windows Admin Center, and that's also possible with PowerShell. But I like it here with our drives. Yeah?
Mhm.
We can just go into the drives, and you see here I added also, you can also add columns here. I added the average latency of the drive, that's read and write, the IOPS of the drive. Yeah, the firmware version is maybe not so interesting here, and the throughput. So
Mhm.
we can dive into a drive, and I will just pick one of the 24 I have. Yeah,
Mhm.
and you see here we will get detailed information per drive. And I'm still
Mhm.
amazed about that, how much data is grasped there. And
Mhm.
this is good to look at, but
Mhm.
this is also very important if you have a storage system like Storage Bases Direct or Azure Stack HCI. We have a lot of data that is spread over the drive. So if we imagine if we have one drive here that is maybe not doing so well. It's not defect. It's
Mhm.
every write, every read is successfully delivered, but it's
Mhm.
slower than the others. Yeah.
Yeah.
This because our data is heavily spread over the drives. Imagine one drive has an average latency of 500 microseconds or even 1 millisecond. It
Mhm.
will slow down the whole system because there is
Yeah.
often data on that drive for the VMs. So we could see that here. Yeah, we
Mhm.
could order about the average latency, and we see we have between 80 and 75. That's very near together. But if we would see 500,
Mhm.
1000
Yep.
microseconds or milliseconds, this drive would be bad. So, and the storage bases direct layer in Azure Stack HCI would even inform us and would say this drive is okay, but it has abnormal latencies. Yeah, we will even get an alert about that, and then you have maybe to change it against a new one. So to
Mhm.
change it. Yeah? Okay, so we have a lot of information here. Bernard,
Yeah.
do you want to see one more? One last one. I love
Yeah.
this one.
Yeah.
You have a
Go
show
for it.
latency and error statistic here. And just till some months ago, there was a bug in this drive latency and error statistic. Um, it was picking some random time span. So here we
Okay.
see now from today, a week back or 5 days back. Yeah, that's
Hmm.
what's interesting to me. Not for example, some a week from November. Yeah?
Hmm.
I want the last data. Yeah. So this
Hmm.
is fixed now, and now it's really useful. You see here in this time frame till now, and from the 8th of May to the 12th, and today is the 12th, we have this drive has done it's a billion, right? Half a billion IOs. So
Hmm.
499 million IOs. Yeah,
Hmm.
it there were 368 gigabyte read and 1.65 terabyte written. The average latency 23.2 microseconds. Amazing. So now we can see here, do we have IOs over 2 milliseconds? And we had no slow IOs when we no failed IO. So we can see heavy latency over 2. No. Heavy
Two
latency
seconds.
over 2
Two.
seconds. It would be amazing, right? But over
Yeah.
4 milliseconds, there are
Mm-hmm.
some. Of the 500 million, 273 IOs were over 4 milliseconds. Yeah?
Hmm.
So you can see, and if we go to 256, 1.5 million of the 500 are 0.3%, so 3 per mil. Yeah, so
Hmm.
you can dive into your storage and just see how one drive is doing. And this is all coming from the cluster performance history. So
Hmm. Cool.
really great stuff. I like it. I like it a lot. Okay. So Bernhard.
I think we should make a stop here, otherwise you won't finish, right? I mean, well, so now, yeah, I think this is a cool exercise that I believe everyone should do when building up an Azure Stack HCI cluster, see and measure the performance of their individual system, and that's sort of the difficulty is, I think, to tell where the difficulties are, or if what you're seeing is the correct thing. But you enlightened us. Thanks for
A
that,
bit.
and
A bit that
hopefully.
yeah, there is more information. Let me add at least one thing. So if we have RDMA network cards that are doing RDMA traffic, yeah,
Mm-hmm.
we talked about that. We have two kinds of RDMA. We have IWAP. IWAP is the safer part because the network cards use TCP/IP to transfer the data between the cards. So in your network, you don't have to configure the switches and so on. But
Mm-hmm.
in the moment, 23, we have a little bit of a problem. There are not much vendors out there who do IWAP as a
Mm-hmm.
protocol. So most of the installation use Rocky, and
Mm-hmm.
Rocky RDMA over converged Ethernet. You have to configure your switches and you have to configure the host because basically
Mm-hmm.
um, Rocky is InfiniBand in Ethernet or InfiniBand in UDP.
Mm-hmm.
So and you set up everything and you do your live migration test and you do maybe your IO meter VM, but you don't get problems in your network. You don't see parser frames. Yeah, that's
Mm-hmm.
important. Um, if a switch can't handle the RDMA traffic, it has to send
Mm-hmm.
parser frames to stop the sender so that it doesn't drop packets because
Mm-hmm.
it is not allowed to drop packets. With VMFleet, you can generate parser frames because we have a lot of traffic between the hosts and we have a three-way mirror. There's a lot of data written to the host from different senders and
Mm-hmm.
you get congestion. So if you use a VM fleet and you look at your switches and you look at your host, you usually should see parser frames
Mm-hmm.
for the PFC classes. Otherwise, maybe something is not correctly configured. Yeah. So VM fleet is a great test to really look at that. Now I will stop. Uh, I think we did enough with our series. We went through a lot of things. Now you see with
Yeah.
670,000 IOPS, it's working like a charm. That's the sweet spot here. That's fine. Cluster is okay.
Mm-hmm.
Um, we
Work
showed a
done, I
lot.
would say, right?
Yeah, we showed the
Work
whole
done.
installation. We
Mm-hmm.
gave you a lot of real world experience. So you should be able to install your cluster and be happy with it.
Yeah. Final words. All good. Take care. and
Bye.
have a great time.